Hi everyone, this is Ashok Kumar, Professor of Mechanical Engineering, Nanda Engineering College, E-Road. Today I am going to discuss about the projection of points in engineering graphics. As we know, engineering graphics is the communication among the engineers and the person who is going to make the component and the persons who is going to assemble the components. What is projections? Projections is the converting the three-dimensional object into the two-dimensional object without distorting the dimensions in both x and y axis. So, for example, this is the object for which we are going to project. So, to completely understand the object, we need one view is not sufficient, so we may need front view, top view, side view, or some auxiliary views also. So first we will see the front view and top view here. So this is the object to be projected. So to draw the front view, the observer is always here to draw the front view. So the rays coming out from the observers are perpendicular to this plane. So this plane, the orientation of this plane is vertical, so that this is called a vertical plane. So the vertical plane, the front view is projected. So to draw the vertical plane, always the observer is here. So the front view will be projected on the vertical plane. Then to draw the top view, always the observer is on the top. So here he view the object, then the corresponding top view will be projected on this plane. The orientation of this plane is horizontal, so that this plane is called horizontal plane. So in front view is projected on the vertical plane and the top view is projected on the horizontal plane. So if we extend the vertical plane beyond the intersection of vertical plane and the horizontal plane, so here that another similarly we extend the horizontal plane beyond the intersection of this vertical plane and horizontal plane. Now these things make one quadrants. So this is the first quadrant, and then this is the second quadrant, and this is the third, and this is the fourth one. The object to be placed is placed in the first quadrant. Its front view and top view are called first angle projections. Then similarly, if the object to be projected is placed in the second quadrant, the front view and the top view will be called as a second angle projections. Similarly, if the object is placed in the third and fourth quadrant, the corresponding front views and the top views are called third angle projections and fourth angle projections. So some assumptions are: the rays coming out from the observer's eyes are sufficient to accommodate the object to be projected. So irrespective of the size and shape of the object, the observers can be able to view the entire object, so that, and also the rays coming out from the observer's eyes are parallel to each other. Suppose the observer is in the position of the front view, so the orientation of the rays coming out from the observer is perpendicular to the vertical plane. Similarly, to draw the top view, the rays coming out from the observer's eyes is parallel to each other, and all the rays are perpendicular to the horizontal plane. So this is called orthographic projection. So to draw the front view, the rays coming out from the observer's eyes are perpendicular to the vertical plane. To draw the top view, the rays coming out from the observer's eyes is perpendicular to the horizontal plane. If the object is placed in the first quadrant, its corresponding front view and top view are called first angle projections. Okay. So here, for example, the observer is here to draw the front view. The object is placed in the first quadrant. So the rays coming out from the observer's eyes are projecting the object, and that projection is fall in the vertical plane. Then so this is the front view. Then similarly, to draw the top view of this object, the observer's position is here. The rays coming out from the observer's eyes are parallel to each other and perpendicular to the HP. Then its corresponding projection will be fall in the horizontal plane. But here the front view and the top view are oriented in 90 degree. So that to bring the both front view and the top view in the same plane, we have to rotate this vertical plane 90 degree in anti-clockwise direction, or we have to rotate the horizontal plane in 90 degree in clockwise direction. So we are following the only one thing universally, so that it was decided to rotate the horizontal plane 90 degree, so that the both vertical plane and horizontal plane both will be coming in a same plane. So this is the vertical plane, and then this is the horizontal plane, and this intersection of HP and VP is this one. So it is denoted by XY. So irrespective of the position placed in the first, second, third and fourth quadrant, after we projected the front view and the top view, we have to rotate the horizontal plane only, and the direction of rotation is clockwise direction, and the angle of rotation is 90 degree. So here, if the object is placed in the first quadrant, the front view will be projected in the vertical plane, then top view will be projected in horizontal plane. After rotation of the HP in 90 degree in clockwise direction, the top view will be coming below the XY reference axis. Now we consider the object to be projected in the second quadrant. So here the object is placed in the second quadrant. Irrespective of the position of the object in the quadrant, to draw the front view, always the position of the observer is here only. So here we assume that the vertical plane is transparent, so that the front view of this object is projected on here. So this is the front view of the object which is placed in the second quadrant. So to draw the top view, the observer's position is here only. So here the rays coming out from the observer's eyes can accommodate the object to be placed, so that he can able to view the entire object. Then one more thing is the rays coming out from the observer's eyes are perpendicular to the horizontal plane, so the top view will be projected on this horizontal plane. Next, after we so this is the front view of the object placed in the second quadrant, this is the top view of the object placed in the second quadrant. After we projected the front view and top view, we have to rotate the horizontal plane 90 degree in the clockwise direction, so that the front view and the top view both will be lying above the XY reference axis. XY reference axis is nothing but the intersection of the vertical plane and horizontal plane. So here, after we rotate the horizontal plane 90 degree, the both front view VP and HP will be lying above the XY reference axis only. So this is the vertical plane. Actually horizontal plane is here. After we make the rotation 90 degree in clockwise direction, the HP also is overlapping with the HP. So the front view, top view both will be lying above the XY reference axis. So it is difficult to interpret the complicated diagram, so that the second angle of projection is normally not followed. Then go to the third angle of projection method. In third angle of projection method, object to be placed in the third quadrant. So to draw the front view, always the observer is here. So the rays coming out from the observer's rays are parallel to each other, and which are perpendicular to the vertical plane. Now we assumed that the vertical plane is transparent, so that the front view of this object is projected on the vertical plane. So this is the front view of the object placed in the third quadrant. So similarly, to draw the top view, the observer is always here. Now we assumed that the horizontal plane is also transparent, so that the projection of the top view of the object is projected on the horizontal plane. So this is the top view of the component placed in the third quadrant. Now after we projected the front view in the vertical plane and the top view in the horizontal plane, we have to rotate the horizontal plane 90 degree in the clockwise direction. So now this is the XY reference axis. So below the XY reference axis, the front view is there. Above the reference axis, the top view will be there. So this is the third angle of projection method. So the third angle, first front view and top view will be placed below and above the XY reference axis. So it can be used. In USA, they are following the third angle of projection method. In India, we are following the first angle of projection method. Now go to the fourth angle of projection method. Here the object to be projected is placed in the fourth quadrant. So the front view will be projected in the vertical plane, the top view will be projected on the horizontal plane. So here the horizontal plane is assumed to be a transparent, so that it will be, the top view will be projected on here. After we projected the front view on VP and the top view on HP, we have to rotate the horizontal plane 90 degree in clockwise direction. If you rotate the horizontal plane 90 degree in clockwise direction, HP will go above the XY reference axis. In the fourth angle of projection method, the top view will be laying above the XY reference axis. The front view will be laying below the XY reference axis. So after we rotate the HP in clockwise direction, it will come below. So in the fourth angle of projection method, already the top view is lying below the XY reference axis. After we rotate the HP 90 degree in clockwise direction, so if the object is placed in the fourth quadrant, so here if the object is placed in the fourth quadrant, to draw the front view, always the observer's position is here. The front view will be projected at here. This is the front view, and then to draw the top view, the observer's position is here. We assumed that the horizontal plane is transparent, so that the top view will be projected on this horizontal plane. This is the top view. So after we make the projection over the vertical plane and the horizontal plane, we have to rotate the horizontal plane 90 degree in the clockwise direction. So if the object is placed in the fourth quadrant, already the top view is drawn below the XY reference axis. After we rotate the horizontal plane 90 degree in clockwise direction, the top view is also lying below the XY reference axis. So both the front view and the top view will be overlapping with each other. So in the fourth angle of projection also, it is very difficult to interpret the front view and the top view. So the first we are following only the first or third angle of projection method only, as here the front view and the top view are lying separately. Either the front view and top view are maybe either in above or below HP, but in the case of third angle of second and fourth angle of projections, both the front view and the top view will be lying either above the front HP or XY reference axis or below the XY reference axis. So it will be very difficult to interpret the complicated diagram. Okay, and first we are going to draw the projection of points, because the points is a dimensionless object. Okay, normally we are going to keep the points around the quadrant, and we are asked to draw the projections. So we will see some examples by which we can able to draw the projection of points. So the question is, a point A is 20 mm above the HP and 35 mm in front of VP. So a point is there which is 20 mm above the HP. So this is the HP. So the entire plane is called HP. The entire vertical plane, this plane is called VP. So the position of the point is given here. The point A is 20 mm above HP. So the object may be placed in the first quadrant or second quadrant. Next one is the point A is 35 mm in front of VP. So the position of the point with respect to VP is always related with respect to the observer. So observer is, to draw the front view, always the position of the observer is here only. So here the 30 mm in front of VP is definitely the object is in the first quadrant only. So already the point A is 20 mm above HP. So 20 mm above HP. So from here it is 20 mm, or it may be at here 20 mm. So according to the first statement, the point A may be either in the first quadrant or in the second quadrant. But the second position is, the point A is 35 mm in front of VP. So here the point A is 35, some distance in front of VP. So this is the position of the given point. So if the same point A is at a second quadrant, means definitely they will give the point A is some distance behind the VP they will give. But here some distance in front of VP is given, so that definitely the position of the object is in the first quadrant only. So this is the correct one. So here the observer is here, the races are parallel to each other and perpendicular to VP to draw the front view. So the front view of the object is fallen on the vertical plane. So here the distance between the object and the horizontal plane is 20 mm. So definitely the distance between the projection of point A and the XY reference line will also be same thing, the same 20 mm. So we are using some notations to mention the front view and the top view. The original name of the point is given as a capital A. The corresponding front view of the particle is given with small a with dash. So small a dash is nothing but the front view of the particle capital A. Similarly, to draw the top view, the position of the observer is here. The top view will be projected over the horizontal plane. The races are parallel to each other and perpendicular to the HP, so that the top view will be projected on the HP at in this point. The top view of the particle capital A is denoted as just small a only. So here, as the races are parallel to each other, the distance between the VP and the particle A is 35 mm. The same distance will be maintained at here also. So here this is the XY reference axis. The distance between the XY reference axis and the top view of the particle A is also same 35 mm. So this is the top view of the particle A. This is the front view of the top particle A. After we projected the front view over the VP and the top view over the HP, we have to rotate the horizontal plane 90 degree in clockwise direction. So the top view will come below the XY reference axis. XY reference axis is nothing but the intersection of VP and HP. So this is the XY reference axis. The front view will be lying 20 mm above the HP. So we measure the 20 mm from the XY. So this is the A dash. So this is the 20 mm. Then after we rotate the horizontal plane, the top view will be lying exactly just below the front view. So after we rotate the horizontal plane in 90 degree, the same distance will be maintained, and which is coming below the XY reference axis. So this is the 35 mm is the distance between the XY and the top view of the particle A. The same distance will be coming below the XY reference axis. So this is the top view of the particle A, which is 35 mm below the XY reference axis. The front view is 20 mm above the reference axis. So this is the projection of the given position of the point A. So we will go to the another problem. A point B is 25 mm below HP. So this is the HP. So HP. So according to this first statement, the particle may be placed either in the third quadrant or first quadrant. So the particle is 25 mm below HP. So the particle may be here or the particle may be here, either in third quadrant or the fourth quadrant. The next statement is the same particle V is 45 mm in front of VP. In front of VP is this portion is the in front of VP. So this is the 45 mm in front of VP and 25 mm below HP. So here if the object is placed in the third quadrant, the specification will be some distance behind the VP they will go, because the position of the observer is here only. So here the front will be projected on the vertical plane, the top view will be projected on the horizontal plane. After we rotate the front top view, the HP will be rotated 90 degree in the clockwise direction. So the both HP and VP, both the front and the top view will be lying at the same side, that is below the XY reference axis. So this is the XY reference axis. So already the front view is fallen below the XY reference axis only, because the VP is below the HP, because the position of the object is in the fourth quadrant. So the front view will be lying 25 mm below the HP, and then 45 mm. The distance between the VP and the object is 45 mm. So after we make a rotation 90 degree in clockwise direction, the object will be coming 45 mm below the reference axis. So this is the top view of the particle B. So the top view will be denoted by the letter B, the front view will be denoted by the letter B with the dash. So this is the projector. So finally this is the reference axis. The front view is 25 mm below the HP, so it is the A dash, and so this is the 25 mm. Then the distance between the VP and the object is 45 mm. So here the 45 mm. After we draw the projection of top view, we have to rotate the horizontal plane 90 degree in clockwise direction. So if we rotate the object in horizontal plane clockwise direction in 90 degree, the top view will be move the 45 mm below the XY reference axis. So here the top view will be lying at here, which is 45 mm below the XY reference axis. So this is the top view, this is the front view, but both the front view and the top view will be lying in a same vertical line. Okay, we will see in another example. So here the point C is 30 mm above HP. According to this statement, the object may be placed either in the first quadrant or in second quadrant. In both the cases, the object will be described as above the HP only. The next point is the object is 50 mm behind VP. So the observer is here. So the behind VP means the point is placed in the second quadrant only. There is no doubt. So the point C is some distance, that is 30 mm above HP and 50 mm behind VP. So here we assumed that the vertical plane is transparent, so the front view will be projected on the vertical plane. So the actual distance between the object and HP is 30 mm. So here, as the rays are parallel and perpendicular parallel to each other and perpendicular to VP, so the distance between the front is denoted with the small letter C with the dash, and the XY reference is same 30 mm, and right. Then so here similarly that we have to draw the top view. In the top view, the position of the observer is here. Here also the rays are parallel to each other and perpendicular to HP. So here the distance between the given point C and VP is 50 mm, which is behind the 50 mm. So the top view will be projected on this horizontal plane. So this is denoted by just a lowercase of the name of the particle to be projected, that is small c. So here also the distance between the XY reference axis and the top view is also the same thing, so 50 mm. So after we draw the top view, we have, so first I will draw the front view. So this is XY, the front view is projected 30 mm above XY. So this is the front view, front is denoted by X dash. After we projected the top view, we have to rotate the horizontal plane 90 degree in clockwise direction. So the horizontal plane will move above the XY reference axis. So already the front view is there. So the top view will be overlapped with the front view. The distance between the XY and the top view of the point C is 50 mm. So the same 50 mm will be, the top view will be moved the same 50 mm above the reference axis. So this is the C. So the distance between the XY and the top view of the particle C is 50 mm, and the distance between the front view of the object and the XY is 30 mm. So this is the projection of the point C. Okay. Similarly, just to pause the video and draw the projection of the point D. Please pause it and then draw the projection. Okay, I hope I have drawn the projection of this point D. So this is the XY reference axis. The point D is 15 mm below the HP, so it may be either in the fourth quadrant or third quadrant. The another specification, the location of this given point is 40 mm behind VP. So definitely the object is in the third quadrant. The point D is 15 mm below HP and 40 mm behind VP. So the front view will be projected below XY. The distance between the HP and a particle is 15 mm. So this is the the 15 mm. The front view will be there. The front is denoted by small d dash. Then after we projected the top view, we have to rotate the horizontal plane 90 degree in clockwise direction. The distance between the VP and particle is 40 mm, so that the top will be projected at here. So here the distance between the reference axis and the top view of the given point D is same 40 mm. After we rotate the horizontal plane 90 degree in clockwise direction, the top view will go same 40 mm but above the HP. So this is the point D, the top view. But both the top view and the front view will be lying in the same vertical line. So this is the projection. So in this manner we have to draw the front view and the top view of the any points which location is given. Thank you.